At what point will the company buy new materials, and by how many units? These questions will be answered by reorder point and economic order quantity. The power to purchase materials is vested to the purchasing department. One of the things that they need to determine is the reorder point. To compute for it, we need to know the following. D. The daily usage of the material by the entity. L. The lead time. It is the time between placing the order and delivery of the items ordered. And lastly, S. The safety stock. It is the minimum level of materials that should be maintained by the entity to ensure that it does not run out of materials. To get the reorder point, R, we need to multiply the daily usage, D, to the lead time, L. Then add the safety stock, S. Let's try this formula in this example. Determine the reorder point, given that the bake shop needs 100 cans of evaporated milk every day. Then it takes 5 days for the supplier to deliver the goods upon the bake shop's order. Additionally, it is the bake shop's policy to maintain 1,000 cans at all times. Pause the video and try to answer. 5, 4, 3, 2, 1. Time's up. First, we need to multiply the daily usage and lead time, which is 100 cans of evaporated milk, times 5 days. The answer is 500 cans. Then we will add the safety stock, which is 1,000 cans. As a result, the reorder point is 1,500 cans. This means that the bake shop will order as soon as their stock of evaporated milk reaches 1,500 cans. Let's answer one more problem. Let's say that another supplier promised to deliver 3 days earlier than their current supplier. Determine the new reorder point and the difference between the two suppliers. Pause the video and try to answer. 5, 4, 3, 2, 1. Time's up. To get the new reorder point, we need to subtract 3 days from the current lead time. Therefore, the lead time of this new supplier is 2 days. Then we will multiply it to 100 cans, which gives us 200 cans. Then we will add the unchanged safety stock of 1,000 cans, which brings us to 1,200 cans, a difference of 300 cans. Finally, the bake shop changed their supplier. Subsequently, the management decided to lower their safety stock to 600 cans. What is the new reorder point? Try to answer this one on your own and comment your answers below. How about economic order quantity? What question does it answer? EOQ, for short, determines the most favorable number of units per order, and it needs the following. Annual demand for the particular material, AD. Costs of a single order to the supplier, also known as ordering cost, OC. Examples of ordering costs are shipping fee, handling fees, and delivery fees from the supplier to the entity. Take note that this is on a per-order basis. And lastly, the cost to carry or store a single item, also known as carrying cost, CC. Examples of carrying cost are electricity to run the storeroom and payments made to storeroom workers. Take note that this is on a per-unit basis. And this is the formula, the square root of 2 times AD times OC divided by CC. Additionally, it is important to know that the total ordering costs is inversely proportional to the number of units per order. On the other hand, the total carrying cost is directly proportional to the number of units per order. Meaning, when the entity orders too much, ordering cost is low while the cost to store them is high. On the other hand, when the entity orders too little, the carrying costs shrink while the ordering costs skyrocket. We need to find the sweet spot where these two are optimal. Let's understand this formula with this example. A bake shop needs 400 sacks of flour per year. The cost to ship an order is 300 pesos while the cost to store each sack is 100 pesos. How many sacks does the bake shop need to buy per order? Pause the video and try to answer. 5, 4, 3, 2, 1. Time's up. By using the formula, it leads us to 48.98 sacks of rice, encircled and double underlined. Always double underline, include the units, and encircle your final answer. An important note here about rounding off answers. If the units are discrete, then always round up to make it a whole number. Some examples of discrete units are the number of people, tickets, days, and sacks. If the units are continuous, then round off to the nearest 2 decimal places. Examples of continuous units are amount of money, number of kilos, hours, and liters. So in this case, the accepted answer is 49 sacks of flour. Let's explore EOQ further with this table. First, for this illustration, we will round up the 49 sacks to 50 sacks. Now, let's compare the different order sizes and see if ordering 50 sacks is the most optimal number of units. In the first column, we see the different order sizes. In the next column, we see the number of orders we need to make in a year for every order size. For example, given that we need 400 sacks per year, and we buy 30 sacks per order, then we will have to order 14 times per year, rounded up of course. Meaning, to determine the number of orders we need to make in a year, we need to divide the annual demand by the order size. In the following column, we see the total order cost, which is determined by multiplying the number of orders per year, times how much it costs per order. As you can see, if we have to order 14 times in a year, and each order costs 300 pesos, then the total ordering costs is 4,000 pesos. Next, we need to determine the average inventory order, which is just dividing the order size by 2. Meaning, if we purchase 30 sacks per order, it is expected to have 15 sacks in the storeroom on average. Then, we multiply the average inventory to the carrying costs to determine the total carrying costs for the year. Meaning, if on average we have 15 sacks in our inventory, then multiplying it with the carrying cost per unit of 100 pesos, will lead us to a total of 1,500 total carrying costs. Lastly, we add the total ordering costs and carrying costs. Then, let's compare them. As you can see, the most favorable order size is 50 sacks because the total carrying and ordering costs is only 4,900 pesos compared to other order sizes. Additionally, as you can see, when our order size is small, the total order cost is high while the total carrying cost is low. In contrast, when our order size is big, the total order cost shrinks while the total carrying cost skyrockets. Want more sample problems? Check the link in the description box below. If you learned from this video, leave a like and comment about what topics you want to see more in this channel. Lastly, subscribe and hit the notification bell so you won't miss any new accounting related content. Up next, we will discuss the different documents used in relation to purchasing materials.